Alright, hi guys. This is something we've been working on in class, and it's how to draw a graph when you're given a whole bunch of different limits. So these are one of these problems where everybody can approach it a little bit differently, but our graphs should all end up having the general same shape. So here we have, if you look carefully, it's a little bit messy, but we've got this limit, this limit, this limit. I'm counting a total of, this one's kind of down at the bottom, 1, 2, 3, 4, 5, 6 different limits that we're going to put on this little graph over here. So what I generally do, and this is a little bit by choice, but I try and focus on the limits that go to numbers like this one. I try and avoid limits that go to infinity until the end. So I'm going to start by noticing that we've got 2 and -1 as kind of our focus points. So 2 and -1 are what I'm going to go over to the graph and mark off. Here's 2. Here's -1. And if it helps, something you could actually do is you could go to 2 and draw like a dotted line. Oops, let's not do it that way though. You could draw like a dotted, it'll look like an asymptote. Doesn't necessarily mean it's an asymptote, but I think it kind of helps people break the graph up into pieces so you can kind of look at it better. So there's my setup. Now we're going to look at each limit from the left and the right hand side. So let's start with, the first one that's up here. Let's start with this one up here. We've got 2 from the left hand side, it's with a negative sign, is going to 1. So 2 from the left hand side is going to 1. So this is what that means. Over here on the left side, over on this side of the graph, this is the left side of 2, we're going to have it going to 1. So 1 is right about here. Here's 1. Put a little mark on the graph. So I'm going to circle 1, and I'm going to put a little line off to the left-hand side so I don't forget. And then I'm going to go down and find, where's 2 from the right? 2 from the right's down here. You see it? 2 from the right is going to infinity. So that means on the graph, on this side, this is the right side, we're going to go up to infinity. I'm going to draw a little arrow pointing up so I don't forget. That's the right side. So now we have the left and the right kind of accomplished. So now we go on to the next limit. Let's look at -1 from the right, and let's look at -1 from the left down here at the bottom of the screen. So we got -1 from the left and -1 from the right. -1 from the right, that's this one, is going to negative infinity. So here's what we're going to do. We're going to go over to the graph. -1 on the right hand side is going to negative infinity, so it's going down. I'll draw a little arrow. And then -1 from the left down at the bottom of the screen is going to positive infinity, which means on the left hand side we're going to have an arrow going up to positive infinity. And so I just put these little markers. These are just, I'm using these just to remind myself which direction to connect my graph. I'm not actually going to piece the graph all together yet. Notice I'm just kind of putting the markers on there. So let's finish this up by looking at the infinities. As x goes to infinity, the graph goes to 0. So that means as we head out this direction, we're supposed to head towards 0. So we're going to keep that in mind. So remember what we had for our arrow up here? We're going to take this arrow and have it slowly go out to 0, like that. And then as x goes to negative infinity, it goes to negative infinity. So that means as our graph heads out from this arrow, I guess it's heading to negative infinity, somewhere in the downwards direction. Now the only piece I have left to figure out is the in between -1 and 2, in between this section right down here. So to figure that out, all I have to do is connect this bottom arrow up to this limit right there. And there is my graph of a potential f of x. And of course, everyone could connect this a little bit different. Like, we're not all going to have matching identical graphs, but the way you go from up here to down here, you can make that really steep or really shallow or whatever, but the arrows have to go in the same direction, no matter what. The way you connect from here to here, same story. You can make it really steep, or you can make it kind of flatten out slowly, but it's got to head to 0, and it's got to head to positive infinity. Those are the things that match. Now, this piece right here, the hole, I'm going to leave it as a hole because they never actually told me what f of 2 equals. Maybe it's equal to 1 and I could fill in the hole. But if it's not equal to 1, if I'm not sure, They just didn't tell me. Oh, it's a terrible question mark. Here. If I don't know what f of 2 equals, then I'm going to leave it as a whole. That's what I'm kind of thinking on this graph. So, there's your answer. There's your graph. And we can make these really complicated. You know, like I said, there was 6 limits here. 1, 2, 3, 4, 5, 6. I could have given you 20 different limits. That'd be a little crazy. But, you know, I could give you more limits to make the graph more complicated. So we're just kind of practicing those skills. All right, hope that helps.